Hello guys, in this tutorial we will walk through the process of creating a simple RAG chatbot. The aim of this project is to develop a specialized chatbot that uses a large language model along with a vector database for storing and retrieving information. By using the RAG method, the chatbot aims to provide accurate and relevant responses. We will be using Python as a programming language. Sometimes the model doesn't know about the topic because it hasn't been trained on that specific data. Also, the model might give incorrect or misleading answers when it doesn't have enough information, especially when we talk about niche areas. RAG improves LLMs by adding more data to them. It has two main components. Organizing data from various sources, named indexing, and the retrieval component acts like a search engine, finding relevant data related to the user's query. This data is then fed into the LLM, which uses this context to generate a more informed and accurate response. In simple terms, RAG helps LLMs give better answers by pulling in extra information when needed. We use Streamlit for front-end UI, Pinecone for vector database, OpenAI for our LLM, and LangChain helps us in building applications that combine language models with other tools and databases. For setting up OpenAI API, first log into your OpenAI account and go to the OpenAI platform. Then navigate to the API section, then create a new API key. For setting up Pinecone, first sign up for a Pinecone account. After registering, create a project and generate API key in the API keys section. Before we are starting indexing, we need to first have the data that our model will use to answer questions. In this case, we need a text file or a PDF about Toronto travel guide, as our chatbot will be answering questions related to this. In data indexing and embedding part, we have three stages that I describe it in the next slide. First, to make the text file manageable, we break them down into smaller segments using a text splitter. In this example, we set the chunk size to 1000 and chunk overlap to 4. This ensures that each segment is of a manageable size and overlaps slightly with the previous segment to maintain context. After splitting the text into segments, we use the Hugging Face embedding tool to convert these segments into vector embedding. These embeddings capture the segmenting meaning of the text and are used for efficient retrieval from the vector database. We initialize the Pinecone client in our application using the API key from the Pinecone dashboard. We then create an index in Pinecone to store the embedded text segments. If the index already exists, we update it with the new embeddings. This process ensures that our vector database is ready for efficient retrieval or relevant data during the chatbot operation. Model setup and prompt engineering part contain three stages. First, we need to create an LLM variable using OpenAI API. Next, define a prompt template for the travel assistant, and finally pass context and question to the prompt for customized responses. We have our embedded text on the vector database. Let's move on to the model setup part. So as I said before, we are using OpenAI for LLM to answer our question. We need to define a prompt that will contain all of the necessary information. This allows us to customize the model to fit our needs. In our case, we will tell the model to be a Toronto travel assistant and answer only relevant questions. Additionally, we need to pass context and question to the prompt. These values will be replaced with the data chunk retrieved from our vector database and the question the user asks for a question. Now that we have first we have do search, that Pinecone database index object and prompt template and the model. We are ready to chain them together. The process starts with do search, pulling relevant documents to provide context. Next, a prompt set refines or modifies the query before it's processed by our model, our large language model. This model isn't perfect, and there are areas for improvement. However, this project provides a basic understanding of creating a RAG chatbot and using vector databases. For future improvements, there are several ways to enhance the chatbot, such as expanding the dataset and optimizing the prompt. Now let's test our chatbot. As you can see, the bot can answer any question related to Toronto travel assistant. It also does not answer a relevant question. Let's try this. Thank you for watching. You can find more information in my GitHub page that I put in the description.